absolute value inequalities. So in this lesson, we're going to talk about how to solve absolute value inequalities. So it's done very similar to absolute value equation. The one difference is, instead of an equation here, like an equal sign, it's an inequality. How does that change it? It changes it in one very specific case, and that is if you see a less than sign, less than is going to be an and statement. So it's going to be a compound inequality. That's what these terms are. So the easy way to think about it is less than, right? A little math trick. Right? Less than and. So anytime you see less than, I'm now saying it, it's an and statement. Than, and. That's all it is. Right? If it's a greater than, then it's an, this is greater than. Helps if I spell it correctly. Greater than, greater, it's an or statement. These are or statements. Great or. So less than, greater. I know, it's silly, but it works. So that's the only difference. So after you isolate the absolute value and you get an end of the less than sign, then it's going to be an and statement, so it's going to be a conjunction. And if after you isolate the absolute value you end up with a greater than sign, then it's an or statement, and you're gonna solve like an or statement. So let's do a couple of examples. So this one here, right? No need to simplify; it's already done for you. Notice how it's a less than statement, so it's gonna be an and statement. So that's how we work, right? We can solve it the exact same way as always. X is less than 3, so that's a positive one, and the negative one. Right, since you're multiplying by a negative, you do have to switch to inequality with the negative one. So that's very important to keep in mind. Right, so when you do the negative one, right, remember we always keep the x alone. We switch the outside. The negative one, we're multiplying by a negative, so it switches inequality. So we have that. So look at this one here. Let's put the numbers. The negative 3 goes first, and then goes 3. Remember, don't get lazy. The left one's going to go here, the right one's going to go there. Which one's lower? Negative 3 is lower, it goes here. 3 is higher, it goes over there. Now let's solve them, right? So we have an open circle on both. The 3 is going to the left. Remember, follow the arrow. If you have a proper math notation, you can just follow it. So it's going this way. And then this guy, I should rewrite it, is going that way. And anytime it's an and statement, we're looking for the overlap. So that's right here. Or you could write it this way. Right? From 3, oops, open circle, to 3. So either way is fine. This is the next one. This is or statements greater than, greater. So exact same concept. X is greater than 3, or x is less than negative 3, right? Because when you do the negative one, you do got to switch to inequality. Write the number line again. Negative 3 is less than 3, so it goes on this side. 3 goes on that side. Follow the arrows, right? This is pointing in that direction. So for negative, it's open circle, we're going this direction. This one's going that direction. Remember that this trick only works if you have in proper notation. If you have the variable on the left-hand side. And then you go in this direction. And since it's an or statement, that works, right? That's both answers work. So there we go. Now let's do a little tougher. So same idea. First thing I do though, don't split it yet. The most common mistake people make, there's a couple mistakes, but one of the most common was they split too early. You gotta isolate the variable first. So let's get rid of that 6. Plus 6 plus 6. So these cancel out. I get the value of 2x plus 1 is less than 11. Now I have absolute value isolated. Now I can split it. Keep 1 the same. 2x plus 1 is less than 11. It is a less than statement, so it's an and statement. And then 2x plus 1 is greater than or equal to negative 11. So remember, when you do the negative one, you have to change the sign in inequality. Then we solve each one separately. So I'm going to kind of try to go to the side here. It's minus 1 from both sides. So I get 2x is less than or equal to 10. And we divide by 2. X is less than or equal to 5. Let's finish this one off before I do anything else. Minus 1. 2x is greater than or equal to negative 12. They're both negative. Anytime they're both negative, you get bigger. So negative 12. And divide by 2. X is greater than or equal to negative 6. Again, divided by 2. I don't switch anything. So let's put this on number line. Negative 6 is smaller, so it goes on the left. 5 is bigger, it goes on the right. And follow the arrows, right? So 5 is going this direction, and it should be a closed circle. And 6 is going this direction, and it's an open circle. And remember, it is an and statement, so we're looking for the overlap. So our answer will be right there. So from -6, close circle, to 5. Okay. Next one. Same concept. Remember, you got to isolate the absolute value first. So -4 minus 4, you get 3 times 2x minus 1 is greater than 6. Now we still have to divide by 3. So you get absolute value of 2x minus 1 is greater than 2. So it is here. I'm going to split it. I'm going to try to do below the number line just to get the space. So 1 keep it exactly the same. Greater, so or, and then 1 change the sign, so less than -2. Now we're going to solve each one of these, right? So add 1 to both sides for this one. 2x is greater than 3, divide by 2. You get a fraction, then nothing you can do about that. 3 over 2, or 1.5. Plus 1 over here. It's a little hard to see, I'm sorry. 2x is less than -1, and then we'll divide by 2. X is less than -1/2. Right, so again, put these on the number line. -1/2 is smaller, so it's on the left. 3/2 is bigger, so on the right. We are greater than 3/2, so open circle to the right. And then we are less than -1/2, so open circle to the left. Right, so it's done very similar to when we did normal absolute values and when we do inequalities. Kind of combine those two ideas. You should get two solutions like an absolute value, and you should treat it like a conjunction statement, right? Like an and or problem. What happens when k is negative? If you remember before, normally with absolute value equals a negative, there was no solution right off the bat. That's not necessarily true for an absolute value. For an inequality, though. So what we do here is we have two choices. You can either solve it like normal and see what you get. You know, you're going to get all real, infinitely many solutions or all real numbers, or no solution. Or you can think about it logically. An absolute value is a distance. So this is always positive, right? Same thing here. This is a positive number. So in this case, you have a positive number is greater than -2. That's true. This is a true statement. Remember, when it's a true statement, it is all real numbers or infinitely many solutions. Any way you want to say it. You don't have to say both, you just say one of them. So your answer is the whole number line, right? Again, if you would have solved it, try the normal problem, you would have the exact same answer. You would have got something that said, oh, all real numbers, right? Because absolute value is a distance, which is a positive number. Positive numbers are always greater than the negative numbers, so true statement. Over here, we have a positive number is less than a negative number. This is false. So this is no solution. Remember, with no solution, you can't graph it at all. So there's that. Okay, last one. Let's do an application problem real quick. Example 4. Members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The cost of each member must be within $20 of the $175 budget. If Hotel A costs $40 a night, Hotel B costs $45 a night, and Hotel C costs $50 a night. Which hotel could they stay within their budget? Right, absolute value inequality to represent this situation. So there's a lot of information there, right? So what's going on? Members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. So that's important. We're going to need it for 4 nights. The total cost must be within $20, $175 budget. So here's the key, right? Within $20, that's our absolute value. Like when we do an absolute value, is less than or equal to k. That's our k. Right? We want to be within $20 over budget. So that's going to be our k. And then our budget's $175. So when we write an equation, we're doing 4 nights of our costs. Let's say cost is x. If you subtract that from our budget, we want that to be within $20. So that'll be our equation, right? So the general idea is the difference between our cost and our budget, we want that to be within $20. So if you subtract those two, it actually doesn't matter which one you put in front, which one you put in back. We want that to be less than equal to $20. This right here is this is actually what we want to solve at the end. Once we figure out our budget, we can figure out, okay, what hotel can we stay at? But for now, we don't need it. We just need what our cost is, what our budget is, and then what's the difference that we want it to be within. And then solving it, you know how to solve this. This is just math. Split it. It's already isolated, so we have 4x minus 175 is less than 20. That's our positive version. And our negative version, 4x minus 175 is greater than or equal to negative 20, right? The negative version, you gotta change the inequality because you're multiplying by a negative. Now, this is a less than statement, right? Less than. So it's an and statement. And then we're just gonna solve it. So, we're gonna solve this. We're gonna add 175 to both sides. And I get 195. 4x is less than 195. Divide by 4. And we're gonna have x is less than or equal to 48.75. Over here, we're going to add 175 to both sides. 4x is greater than or equal to 155. Divided by 4. And then x is greater than or equal to 38.75. So we have to be between, if you look at this, if we made a number line, 38.75 and 48.75. We have to be between those two. So between 38.75 and 48.75. What hotels fall between that? Hotels A and B. We can't splurge for hotel C, but we could easily fit between hotels A and B. So hotels A and B fall within the budget. Okay, so that's how you do an application problem. So a little concept summary, right? And remember when we solve, so recap, right? When we solve an inequality by itself, you don't have to do the less than greater than. It's just inequality. So you usually get two numbers here as an answer, right? First thing you do is isolate the absolute value. And then you split it. X minus 17 is equal to 9. X minus 17 is equal to negative 9 plus 17 on both sides. You get x equals 26 plus 17 on both sides. You get x equals 8. So in this case, you get 2 points, 8 and 26. Right? Those are your solutions when you solve an equal sign, an absolute value equation. Two solutions. When you're solving an inequality, right, less than is an and statement. So when I solve this, x is less than or equal to 1, and x is greater than or equal to negative 1, right? You got the negative one, you also got to change the inequality. So when you have this one, they should overlap. You are bigger than negative 1, but you're less than 1. And if you have an or greater, then you should get them going opposite sides. So x greater than 2, or x is less than negative 2. So it looks like this. Anyway, that's the lesson.